Hello everyone, welcome to our YouTube channel. So today we will discuss about another machine learning model, which is basically movie recommendation system, which is based on our content, popularity, and collaborative. So this model will predict the recommended movie on the basis of our data. So let's discuss our workflow, how our workflow will be look like. So we will input our data, then we will pre-process it, and on the basis of the title, content, keywords of our data, we will recommend our movie. So basically, we will input our movie. We will use cosine similarity function. This will help us how identifying the some common similar recommendations according to our input and according to the list that we will build after cosine similarity. Then we will predict the list of movies in sort function so that it will recommend movies on their priority basis. So let's go to our collab and discuss our code. So first import our libraries, import numpy as np. So basically let's comment it libraries. So first import numpy as np. Then we will import our pandas as pd to read our file. From field scalar and feature extraction text, we will import our TF-ID vectorizer. Basically, it will convert our text data into numerical form so that our machine could learn this numerical data easily. Okay, so we will import our TF-ID vectorizer. So then we cosine similarity through scalar matrix pairwise. This will help us in identifying the similar movies and predicting movies. Okay. So now, next cell, TF-ID vectorizer, as I explained there, cosine similarity will help us in identifying the similar movies according to their common numerical similarity with, okay. So I will explain it when it's come its own section. So I will explain cosine similarity in detail. So let's make a new function. Let's read our file. So now read our file. We will make a new variable movies data. First we import our file data into our collab. It's been loading. So now make a variable noise underscore data with the help of pt.read function underscore csv. We will give it our files path by just now copy path and pass it to our function. So now run the cell. So pt is okay. We have not installed our libraries, but now we installed it. So our data has been read. So now we will check the shape of our data. First we will check the head. We will check our first 5 rows with the help of head. So as you see now, our data has been displayed in tabular form. So basically these are our main components: genres, keywords, etc. These will help us in predicting our data. So now we will display our shape, how many columns and how many rows are there in our data. So movies data.shape. Now check. As there 4,803 rows and 24 columns. So now we will select features that will impact our recommendation system. Okay, so we will make a command select features that impact, select that impact, recommendation system. So make a variable name, select features. So these variable like genre, keyword, original language, title, popularity, spoken, directed, these will help us in predicting our data. As you know, this tagline, title, cost also affect the recommendation of movies. Okay. So make a variable here, select feature, we will give it our list. Okay, list of the features like keyword, genre, tagline, cost. The director who is directing this movie also has an influence on movie recommendation. Popular directors like, okay, genre, either it is action, thriller, in every kind of genres affect movies recommendation. So we'll pass it our list, keywords, tagline, cost, tagline, cost, director. Then we will predict our features. We will print our features. So run the cell. So as you know, our list has been displayed. So now we will replace null values with null string in our features. As would genres maybe have some sort of null values, so we will simply replace them. So replace null values with null string. So for this we will make a we will use a for loop. So for features in select feature means every feature for single feature in a feature selection which have a list of features. Okay, feature in select features variable that we have directed there. Now movies data, go to our movies data variable. So movies data variable, its feature, movies dot with features. So go to movies data features, movies data feature dot fill now. Okay, we will use fill now function to replace our null values with the null string. Okay, feature of fill now with null string. This is null string with the fill now function. Okay, movies data features dot fill now. Okay, now run our cell. Okay. So we will basically combine all these features. Combine all these features. Combine features, movies data feature genre, movies data feature keyword, movies data feature tagline. We will combine them one by one. So basically just copy paste their names, like copy paste their genre, pass it to our movies data variable feature. Okay, now copy paste this and one by one replace the name of their features one by one in movies data. Okay, so movies data, simply pass it our keyword. Now copy paste it and repeat it. So now change their tagline, cost and director, cost, director. So this has been combined and we have now run this cell. Okay. Now print our combined features. So run this cell. Okay. So now make a new cell. So vectorize our data. Okay. We will make a variable text to vector. We will convert our text to vector because our machine needs a numerical value, a vector value. So with the help of TF-IT vectorizer, we will pass this function to our text to vector variable. Now we will feature vectorize. We will do feature vectorization. As you know, we will tagline value genre are in vector text form, so we will convert it to vector. So text to vector variable in which our TF-IT vectorizer has been stored. So we give it our combined feature for variable name. So give it our combined feature variable name to read.transform. We can give it fit and transform, means convert our combined feature into fit and then transform into vectorizer. So now what is the issue? Subject has no attribute lawyer. Okay. Lawyer. Let me check. We have made a mistake there. We did not add this. We have just only add a comma. So add plus there. So this is our mistake. So let me correct it. Just replace comma with plus. Now run our cell. Run combined feature. Yes, now this has been great. Now run our TF-IT vectorizer. Now feature vectorizations. Now we will print our feature vectorization to see if our text converted into vector. So give it our feature vectorization variable. So now run cell. Yeah, as you see, our data has been converted into vector form. Yeah, in numerical form. Okay. So these are basically numerical values. Okay, correspondingly to their column to their rows. Okay. So now we will check our similarity shape. So now we will check our similarity, means the ones that are more close to each other. So similarity is equals to cosine similarity. Similarity give it our vector feature vectorization variable. So cosine similarity is basically if we predict one, so cosine similarity, with the help of cosine similarity, it will give the numerical value which is close to 2, which is close to 1. Basically, it will give us a closely related numerical values. Okay. So just run our cell. Now print our similarity. So we will first check our similarity shape column. So basically these are similar rows. Okay. We have to predict our values from this similarity shape. Okay. So now we will input our name. Basically we will give any name to our recommendation system and we will predict our movie through it. So movie dot underscore name, input, enter the movie. So enter the movie, run this cell. So basically we have run the cell. Now we will pass our list. Okay. So now make a new cell. So now make a new cell. Now we have list of movies. We will make a new variable list of movies and we'll give it a title. Okay. As if we give a movie name and it should be stored in the movie list, then the movies in the movie list must have some sort of title. So we will make it a list. Okay. We will make our input values to our movies list. So we will basically take a list title. We will basically take a movie's title and pass it to our list, to list function. So if it will make the list of our input values movie. So now print movies. Basically, these are the movies which are in the movies data. So we will pass it our any name. So we will enter our movie name. So these are the movies in our data set. So these will be stored into a list. So print our list movie. So these are the movie list in our data set. As you see now, Avatar, Dark Knight and so on. So now in the next step, we have give our list. We have print our list and we have give our desired movie name. And so now we will make a close check. Means from this list, we check our movie, our recommended movie. So find close match which are closely related to our input movie from that list that has been displayed there. So with the help of difflip.get close match function, difflip basically a library which will help us to find closely related things, closely related movies or closely related objects or sort of things. So we will pass it our movie name. So we will pass it our movie list name. So first we have find close match. First we have to import our difflip library. So import difflip library. This difflip library will help us to find close match according to our movie in our movie list name. So Spider-Man, our input movie, Inside-Man is closely related to Inside-Man is closely related to Spider-Man, Superman also action movie. So these are closely related movies. So now these are the movies that are closely related to each other. So now I think we have to make another input to see how our next movie look like. So we will give it run our cell again. We will input our new movie name. Let's input Fast and Furious and see how many movies are closely related to these movies through cosine similarity and difflip library. This will help us to now see Fast and Furious and Too Fast, Too Furious are closely related to each other. So now make a new cell. So now we will find the index of our input movie. Okay. So here we will make a first comment. Underscore find the index of movie with title. Find index of movie with title. So now we will give it our variable movie index. So go to our movies data to get our movie data title. Find close match which is equal to close match and its index value should be started from 0, not value 0. Okay, give it our index value which is started from 0. So basically it will give the index of our input movie according to its index in the list. Okay, because Fast and Furious might be at any index of the list. We have 4803 movies as per our data, so it will give the index, the position of Fast and Furious in the list. So basically, it is at 99 index in our list. So basically, it is a 100th number in our list. Okay, Fast and Furious is at 99 index in our list. Okay, we will give it our title. So now, in the next step, we will list our similar movies. Okay. On the behalf of our similarity search, we will list our similar movies. And if we so similarity list, similarity list make a variable. So now we will use list function. Enumerate means convert it into list similarity movie index. So basically, similarity is our similarity, cosine similarity. So it's on the behalf of movie index, it will give the similarity values. Okay, so give it a list. So as you see now, our list has been displayed as 0 and a 0.02, 1 and 0. So as you see now, this list is not sorted. Sorted now. Some are bigger values come before, and these are some kind of random values. So basically, after getting our random values, with the help of sorting of function, we will sort our values in descending order. The more value, the more priorities in similarity search will come at 0 index as 1. The less priority value will come at 1 index and so on. So basically, we will descendingly, on the behalf of priority list, we will print our values. So make a sort similarity list variable, sort our similarity list. Sort our similarity list. Sort our similarity list. So give it our similarity list. Key lambda x1 means as you reverse to mean descending order. So reverse to simply mean descending order. Okay. So now as our x colon x1 lambda, it means at our 0 index, like you see 0.02, at our 1 index 1. So basically it will change our second variable. As you know, 0.02 is at second 1 index. So basically it will change these values, lambda x1. If lambda x0, it means it will change the index value. But now we are changing similarity value. So simply we will print our similarity list. As you now check what is the issue. Run again. Now run again. As you see now, at our 99 index, we have similarity 6 over 6, similarity of 1. At our 284 index, we have similarity of 0.27. And as you see now, our similarity value x under colon x1 are decreasing. Reverse is equal to 2 is being true. So basically, these are decreasing descendingly. So this is how our sort similarity list will work. And you see now, these have been decreasing. Reverse is equal to true. So 0.27, 99, 1, and so on. So now we will suggest and print movies based on the index. So basically, we will make a loop of our data. So give it in a function, we will give it in a loop. So our function will repeat repeatedly. So print movies name based on the index. So we will print movie suggested name for me. Print. Basically, we are making a title. So movie index, movie suggested for me. So we will first initialize our variable I is equals to 0. For movie in similarity list, index should be movie at 0. Index should be at 0. So we will give it our 0 index. Now we will check movie title. We will make a variable movie title. So give it our movie underscore title is equals to movies data. Movies data is basically our variable in which our whole data has been stored. Okay, movies data. So movies data dot index is equals to index. Okay, so our 0 should be equal to 0, our 1 equal to 1. So give it our title and get its title dot values, it is equal to 0. So movie title. So basically now if I for less than 40, basically we are given a list of 40. We will predict our first 14 movies. Okay, so we will initialize our variable to 0. It will give our first 14 movie according to our input movie name. So it will give our first 14 movie on the behalf of cosine similarity, and the flip first 14 movies will be get according to our input value first 14 high priority movies. So movies title. So give it our I means starts from our variable 1 by 1. First 0, first 1, then 2, 3, 4, and so on till 40. So we will separate it by comma. We are just basically making it some kind of understandable. So hashtag 0 dot. This is how our data, our list will look like. First, it should be index, comma, separated by comma, then the movie title corresponding to its index value. So now see for comma. So now we will iterate it. Means process these loop until reaches is 40. Okay. So what is the issue? Okay, we'll just denote at the colon. So make it a loop. So now, okay, make remove indentations. So now see, our movies has been predicted one by one according to the movie's name correspondingly. This is how our movies data recommendation system will work and predict our movies according to our input values. So this is our one correspondingly until 39 as we have given the condition. So that's all from my end. Thanks for watching our video. Thank you.